Welcome to G Fun Facts Online. Imagine you're in a canoe. You can lean a little to one side, and it rocks, but it settles back. But if you lean too far, you cross a point of no return, and the canoe capsizes. Our planet's climate system works in a similar way, and right now, we are leaning dangerously far. We're talking about climate tipping points, critical thresholds that once crossed can trigger abrupt, accelerating, and often irreversible changes. And this isn't a problem for the distant future. According to a 2025 report by 160 scientists, the world has already reached its first major tipping point, the widespread dieback of warm water coral reefs. As we approach 1.5 degrees Celsius of warming, we are teetering on the edge of a domino effect that could fundamentally alter our world. Today, we're diving into the science of these tipping points, exploring the colossal systems at risk and what it means for all of us. Let's start with the Earth's frozen regions, the cryosphere, where some of the most consequential changes are already underway. The Greenland ice sheet is a true giant, a colossal reservoir of fresh water holding enough ice to raise global sea levels by a staggering 23 feet, or 7.2 meters if it were to melt completely. Its melting isn't a slow, steady process. It's accelerating due to powerful feedback loops. One is called the melt elevation feedback. As the ice melts, its surface gets lower. Lower altitude means warmer air, which accelerates melting, which lowers the surface further. It's a self-reinforcing cycle. At the same time, the ice is getting darker. As snow melts, impurities like dust and soot concentrate on the surface, and the ice grains themselves get larger. This reduces the ice's ability to reflect sunlight, a property known as albedo. A darker surface absorbs more solar energy, which, you guessed it, causes more melting. Greenland is already responsible for 20% of global sea level rise. Even if we stopped all emissions today, a certain amount of melting is already locked in, guaranteeing sea level rise for centuries. But the danger doesn't stop at the coast. The massive influx of cold, fresh water into the North Atlantic disrupts ocean circulation. It can weaken a vital current system called the Atlantic Meridional Overturning Circulation, or AMOC. A slowdown or collapse of the AMOC would have profound consequences for weather patterns across the globe. Now let's travel to the other pole, to the West Antarctic ice sheet. This is another giant, holding enough ice for about 10 feet of sea level rise. Unlike Greenland, much of the West Antarctic ice sheet rests on bedrock that is below sea level. This makes it uniquely vulnerable to something called marine ice sheet instability. The problem starts with warm ocean water. As warmer currents flow beneath the ice shelves that extend from the glaciers, they melt the ice from below. These shelves act like a cork in a bottle, buttressing the massive glaciers behind them. As they thin and weaken, the glaciers they hold back begin to flow faster into the ocean. The point where the glacier loses contact with the bedrock and starts to float, known as the grounding line, retreats inland. This exposes ever thicker sections of ice to the warm ocean, creating a runaway feedback loop. The Thwaites Glacier, often nicknamed the Doomsday Glacier, is the poster child for this process. Its collapse alone could trigger a wider collapse of the entire West Antarctic ice sheet. Thwaites and its neighbor, the Pine Island Glacier, already contribute to about 5% of global sea level rise, a stark warning of what's to come. The third critical element in our cryosphere crisis is permafrost. This is the perennially frozen ground covering vast areas of the Arctic. These frozen soils are a ticking carbon bomb. They hold an immense amount of organic carbon, estimated to be roughly twice the amount of carbon currently in our atmosphere. As the Arctic warms at a rate nearly 4 times the global average, this ancient carbon is being unlocked. When permafrost thaws, microbes begin to decompose the organic matter, releasing carbon dioxide and methane, a potent greenhouse gas, into the atmosphere. This release of greenhouse gases further warms the planet, leading to more permafrost thaw. It's another dangerous feedback loop. A global temperature increase of 3 degrees Celsius could lead to the melting of 30 to 85% of the top permafrost layers. The consequences are dire. Beyond accelerating global warming, the thaw is already causing massive damage. In Arctic communities, roads are buckling, buildings are tilting and cracking, and pipelines are rupturing as the once solid ground turns to unstable mud. The estimated cost of this infrastructure damage could reach tens of billions of dollars by 2050. The crisis isn't confined to the ice. Our planet's living systems, the biosphere, are also at a precipice. The Amazon rainforest, often called the lungs of the Earth, stores between 150 to 200 billion tons of carbon and generates weather systems that stretch across continents. But this vital ecosystem is under immense pressure. Deforestation for agriculture, combined with rising temperatures and more frequent droughts, is diminishing the Amazon's ability to generate its own rainfall. This is pushing the rainforest towards a tipping point, where vast sections could irreversibly transform into a drier, savanna-like ecosystem. This transition would be catastrophic. A significant portion of that stored carbon would be released, further accelerating climate change. Some models predict the Amazon could become a permanent source of carbon emissions as early as 2035. The loss of biodiversity would be incalculable. Then there are the coral reefs, the vibrant underwater cities that support a quarter of all marine life. As we mentioned, scientists believe this is the first major tipping point we've crossed. Reefs are incredibly sensitive to temperature. When oceans get too warm, corals expel the symbiotic algae living in their tissues, causing them to turn white in a process called bleaching. While they can survive bleaching, prolonged or repeated events lead to mass death. At the same time, as the ocean absorbs excess CO2 from the atmosphere, it becomes more acidic, making it harder for corals to build their skeletons. Scientists warn that even if we limit global warming to 1.5 degrees, we could still lose 99% of the world's warm water coral reefs. The collapse of these ecosystems would be devastating for marine biodiversity, fisheries, and the nearly 1 billion people who rely on them. Beyond these major systems, scientists are watching other potential tipping points. The vast boreal forests of the Northern Hemisphere, another critical carbon sink, are becoming more susceptible to massive wildfires that could release huge amounts of carbon and prevent forest regeneration. There's also a more frightening, though still uncertain, possibility involving the breakup of stratocumulus cloud decks over subtropical oceans. These clouds reflect a huge amount of sunlight back into space, helping to cool the planet. Some climate models suggest that at very high CO2 concentrations, around 1/200 parts per million, these cloud decks could become unstable and break apart. If this happened, it could lead to a rapid global temperature spike of as much as 8 degrees Celsius. Perhaps the most frightening aspect is how these tipping points can interact. The crossing of one can increase the likelihood of crossing others, like a row of dominoes. For example, meltwater from Greenland weakens the AMOC ocean current, which in turn could shift rainfall patterns and destabilize the Amazon rainforest. Thawing permafrost releases more greenhouse gases, warming the planet and pushing every other tipping point closer to the edge. This domino effect could push our planet onto a hothouse Earth trajectory. This is a scenario where the planet's own feedback loops take over, driving continued warming even if humanity were to stop all emissions. In a hothouse Earth, temperatures could stabilize 4 to 5 degrees higher than today, with sea levels 10 to 60 meters higher. Large parts of the planet would become uninhabitable. The human cost of these changes would be staggering. Food and water security would be under severe threat. The collapse of coral reefs would decimate fisheries. The irreversible sea level rise from melting ice sheets would displace hundreds of millions of people from coastal cities. The economic costs are estimated to run into the trillions, potentially destabilizing the entire global financial system. While this picture is grim, it is not without hope. Just as there are negative tipping points, Scientists are also identifying positive tipping points. These are self-reinforcing shifts in our technology, economies, and societies that can accelerate the transition to a sustainable future. We are already seeing this happen. The cost of solar and wind power has plummeted, making them the cheapest sources of new electricity in many parts of the world. As more renewables are installed, costs fall further, driving more investment and adoption. The same is happening with electric vehicles. As they become more common and cheaper, more charging infrastructure is built, which encourages more people to switch, creating a positive feedback loop. Social attitudes can also reach a tipping point, where public concern about climate change drives overwhelming political pressure for action and a shift in norms toward sustainable lifestyles. The challenge is to intentionally trigger these positive tipping points through smart policy, targeted investment, and collective action. The science is clear. We are standing at a crossroads. We are dangerously close to triggering a cascade of changes that could make our planet far less hospitable. The collapse of our coral reefs is the first major domino to fall, a stark warning that the time for slow, incremental change is over. The challenge is immense, but the window of opportunity to avoid the worst outcomes is still open, though it is closing fast. The path forward requires a rapid transformation of our energy systems and our economies. It requires us to actively push for those positive tipping points. The choices we make in the next few years will determine whether we slide into a hothouse Earth or steer our world towards a safe and sustainable future. The time to act is now.